Hello, everyone. So as promised, I will be solving the questions in full. This is just to be sure that you are able to assess the full solution outside of the time frame of 1 hour. So basically, on the first question, as you can see, say let xi, I1 to n be a set of n pair of numbers, and let upper bar indicate the corresponding average, e.g. x bar summation xi. Prove that the following is true. The first proving is that the summation of xi deviation from x bar is equal to 0. So, and the second question, deviation of xi from x bar times deviation of xi from y bar summation is equal to this. And the third question as well, a bar times x bar equals to a times x bar, where a is a constant. The x plus y bar equals x bar plus y bar. Now, and e, of course, that suppose n is even and it divided the set of xi into 2 equal half and denote their corresponding averages. And so xi equals 1 over n over 2 summation I equal 1 to n over 2 xi, then x bar square 2 equals 1 over n over 2 summation I from n over 2 plus I to n summation xi, of course. So to prove that the average of xi is equal to x bar equals xi x1 bar x plus x2 bar all over 2. So now the solution, let me start from A. So starting from A, so summation of the xi deviation from x bar. So how do we prove that that is 0? So from here, if we open up this bracket, we have this. And if you open up this bracket as well, if you open up this bracket, we have this, right? So, but we know from x bar that the formula for x bar, which is summation xi over n, right? When you cross multiply this, you have x bar, n times x bar equals to summation I, right? Of course, I ranges from 1 to n. It's summing from 1 to n, right? So if that is true, then that means we can replace summation xi with n over x bar, right? We can replace this with this guy here, right? Just replace. So let's go on. So now, having replaced that, I have this. Then for this, you see that we are summing x bar from 1 to n, but x bar, although it changes with respect to, I mean, it's not a function of x, it's not a function of I, right? X bar is not a function of I. So, and as such, also, because of that, because it's not a function of I, right? So when you sum it, when you sum x bar, what happens is that it will become n times x bar, n times x bar, right? So more like a constant, right? But this is not exactly a constant because it changes with respect to as the sample size changes, so the mean changes, right? So, but because it's not a function of x, it's not a function of I, so there's no I here, right? So it now becomes nx bar minus nx bar, which is equal to 0. So for the second question say that you are going to prove the second question that says this equals xi equals 1 and x bar I minus x bar yi, right? So now we want to prove that this is equal to this. So let's focus on this now. Now let's expand this. So if we expand this, we have, open the bracket, we have summation I n x bar 1 minus x bar yi minus y bar summation I equals 1 and xi minus x bar, right? So when you expand it, this multiply this by this minus multiply this by this. So I have this. So then if you look at this guy, we have proved this guy in the first question that this guy equals to 0, right? We put that this guy is equal to 0. So now let's substitute this 0 for this. So we have summation n I equals 1, x bar I minus x bar yi, right? Minus y bar times 0. So when this becomes 0, we arrive exactly at what we are asked to prove. So we have summation n I equals 1, xi minus x bar yi proved. So that's very straightforward. Now let's go to the third question. Third question is you have to prove that this equals this. That is ax bar equals a times x bar. Now that is where a is a constant. Where a is a constant. Where a is a constant. So now here, a bar here is not a constant, right? But where this a is a constant, but this a bar is the mean of a. So now we can expand this now, as we can expand it to give what's the definition of this. So the definition of this means this bar equals 1 over n summation n I equals 1 axi, right? So now we've expanded it as the meaning of ax bar. So now there is no bar on this a again. Now it now becomes a constant, right? A is a constant. So we can bring this a out of this summation sign. So that would be a over n summation I equals 1 n. So we have xi. So of course we know that this here all over this n is the definition of mean. So that means we have a times 1 over n summation I, I'm summing xi from 1 to n. So this becomes a mean of x, right? That's proved. So that is also straightforward. Now let's go to the D part of the question. The D part says yeah, I think I need to write the D parts out again. So the part says to prove that x plus y bar equals x bar plus y bar, right? So that the mean of the sum equals the sum of each mean. So also let's start from the left-hand side here, right? So here we can expand both. Let's expand this guy. So this means 1 over n summation n. So that is summing both of them from 1 to n. N is the sample size, right? So we can open up the bracket. If we open up the bracket, we have 1 over n summation ni summing xi plus 1 over n summation yi, right? Summing from 1 to n. So if you now look at this, now this is the mean of x, this is the mean of y. So that proof exactly what we have to prove. Then let's go to the E part. The E part here. The E part has to for the E part, has to prove that suppose n is even and divided by the set of xi into 2 equal half and denoted by their corresponding averages. That is the first average, second average. So now the n is the total sample size, right? So, but the population, the sample now is divided into two equal parts. So the mean, that is the mean of the first part, the mean of the second part. So here, if you look at this clearly, so you see divided by 2. That's because it's divided because the sample size, the sample is divided into 2. So divide the n by 2, divide the n by 2, right? So here, the first sample now is here now means it's summing from the first number, right, to n over 2, that is to the half. Then this continue from that half. So you start from that half, see, n to the plus 1, up to the last number, right, in the sample, right? So that means if this is, say, if the sample size is, say, 100, right, 100 sample size, so that means this is looking for the average or the first, from the first number to the 50th number, to the 50th number, you see? So because 100 over 2 is 50. So this starts from 50 plus 1, from 51 to 100. So you're looking for the mean of the first half, then this look for the mean of the second half. So now you have to prove that the average of xi, that is the main mean, the main sample mean, is equal to the average of each of the half part sample mean, right? The half mean, the first part mean, the second part mean divided by 2. So it's equal to the main sample mean, right? So that's what I asked to prove. So let's prove that. So it also is straightforward. So now let's start from the from the main mean, because yes, from the left side, we have x bar equals summation xi over n, that is I from 1 to n, right? Then we can expand this to be x bar equals summation n over 2, that is I from 1 to 2, xi plus summation I equals n over 2 plus 1 summing to n xi, right? So here, if you look at this, all over n, because now it involves both of them, you understand? So here we have, you know, your n over 2 with the 1 over n over 2 here plus 1 over n over 2 here is n, right? Half plus half give us the n. So we have, let's say we have n over 2 plus n over 2, right? Right, so 2, 1 in this is n plus n, that's 2n over 2, 2 cancel 2, we have n. That's how we got this n, right? So from the main question, you know, this one is divided by half, right? This is divided by half, divided by n over 2, n over 2. So when you sum those together, you get n. That's why we got this n, right? Because now we are dealing with the main sample mean, not the mean of half part and half part again, right? So if we have this, one thing that we can manipulate this equation here to say, okay, x I here, I equals 1 to n over 2 plus summation I equals n over 2 plus 1 xi n, right? Right, so now we have all over, you know, with this now, we can actually, yeah, now this is all over n, right? It's all over n. But what we can do actually from here, so what we can do actually is that we can actually multiply half. Look at this place. We can divide this by 2 and multiply this by half, right? You can divide this by 2 and multiply this by half. So what does this mean? I mean, if I have a over b, right? Right, if I have a over b, assuming this equation, I can divide this by, say, half, right? But divide this b by if I divide this by half, so half divided by 2, I can multiply by half 2 as well. So what happened? We have 1 over 2 times, if this, you know, this is a over b, right? So when this division change to times, you know, your basic algebra, right? We have times 2 over 1. So these 2 cancel out these 2. So we are left with a over b. So basically, dividing this by b by 2 and multiplying this by half, means you have not done anything to the main equation. You still arrive at the main equation, right? You still arrive at the main equation by dividing this by 2 and multiplying this by half. So basically, that's what we want to do to this equation. So here, if you divide this by 2, you end up having the whole of this, n over 2, the whole of this, n over 2, then times 1/2. And having done that, if you look at this guy, you find that this guy is the mean of that first mean of x1. So you have mean of x1. If you look at this, you find that the mean of x2, right? Times this half divided by 2. So that is proved. It's very straightforward, actually. Just manipulating this equation. So now let's go to the next one. The next one. Yeah, I think this next one. So let me show it clearly so you can all see the question. So let x, I, y, I, z, x, y, I, comma, y, I, z, I, that's comma as well. I is from 1 to n, be a set of n triples of number. Prove that the variance of xi plus yi equals variance of xi plus variance of yi plus 2 covariance xi plus yi, right? So, okay, then the B part, say we should look for the covariance of xi, comma, yi plus zi equals, to show that it's equals to the covariance of xi, comma, yi plus covariance xi plus zi. So, and hence otherwise show that the variance of these, right, equals variance x plus variance y plus variance zi plus 2 covariance xi zi plus 2 covariance xi yi plus 2 covariance yi zi, right? Then of course the third one says prove that variance of x equals this. Then prove that if x is a random variable and a is a constant, then expected value of a equal a, variance of a equals 0, variance of x, comma, a equals 0, variance of a, x equals a squared, variance x. Then the v part, prove that x and y are random variable and a and b are constant. Then variance of ax minus by equals a squared, variance b plus b squared, variance y equal minus 2ab covariance x and y. So now let's start from the first one. Let's start to prove from the first one. So solution, the A part now. So the first thing to do here is to, of course, write out the formula for this variance of xi plus yi. Of course, we know the formula for variance, but now, instead of having just one single variable here, we are having two variables. So the variance is 1 over n summation I1 up to n, is summing up to n. So we have xi plus yi minus x plus 1 y all square. So basically that's the meaning of this variance. Then here we can collect like terms. To collect like terms, we have 1 over n summation n I equals 1. So we have here I xi minus x oh, I think I'm sorry, you need to have by here. Yeah, that's an oversight. We need to have by here because the variance is deviation from the x bar, right? So x bar. So plus yi minus y bar all square. Now that we have now collected like terms. So we can now expand this, from this is more like, it's more like what we know as a plus b all square, right? So we can expand this. When we expand that, we have 1 over n summation n I equals 1 xi minus x bar square plus yi minus y bar square plus 2 xi x bar yi y bar. Okay, so having expanded this is what we have. Now from the expansion, then we can open up the bracket. We can open up this bracket. We can open up this bracket. So if I open up this bracket, we have 1 over n summation, it is summing 1 to n xi minus x bar square plus 1 over n summation I1 up to n yi minus y bar square plus 2 1 over n summation I from 1 up to n xi minus x bar times y as the covariance of x and y, right? Yeah, this is what I have after expanding. Now, if you look closely, you find that this is same thing as the variance of x. This guy, everything here, same thing as the variance of x. Let me write variance here. Variance x. This is same thing as the variance of y. Variance y. And this is the 2 times the covariance of x and y. 2 times the covariance. It's not the variance, but the covariance of x and y. Right. So basically that is proved from what we are asked to prove. Look at it here. We are asked to prove, right? So that's exactly what we arrived at. Now let's move on to the next one. The next one, the B part, asks us to prove this, that the covariance of x and yi plus zi equals the covariance of x times y, x comma y, then plus covariance of x comma z. That's the second one I have to prove. So here, first thing to do is to expand. You have xi comma yi plus zi, right? So the first thing to do here is to write out this. What's the formula for this? What does this mean? So this means 1 over n summation I on xi minus x bar, see, times yi minus zi minus y plus z. So now, if you remember from the covariance of x, say the covariance of x and y, if it's just the covariance of x and y, right? So we have what we have here is everything here will be it will just be just like what we have here. It's going to be something like this, right? xi minus x bar, yi minus y bar, right? If what we have is just the covariance of x and y. But now this two guy is taken as a single variable, right? That's why we have it this way. So this guy is taken as a single variable, right? So let's assume the whole of this is y, the whole of this is y, the whole of this is y, just like this, right? So you can see that this remains the same because it's just x we have. So with that, we can expand further. So to expand, you can open this bracket, multiply this by this, multiply this by this. So we have 1 over n summation I. Summing from 1 to n, we have xi minus x bar yi minus y bar 1 over n summation to n xi minus x bar ci z bar, right? So we've opened up this. So having opened up this now, you see that this is exactly the covariance of x and y, right? What we have here, I think, yeah, just the covariance of x and y, not. So here we have the covariance of x and y, right? And this is the covariance of x and z, right? So we have here the covariance of x and z, right? So I think that's exactly what we are asked to prove, right? So xi, yi, xi, zi. So that's exactly what we are asked to prove, right? So with that, let's go to C, which that's proof. So the C part says, hence otherwise show that the variance of xi plus yi plus zi equals this. So the C part prove that this equals this. So the first thing is to expand this. Let's expand that. So you can just use the some of the solution from the A part and the B part to arrive at what we are trying to arrive the C part. So we have variance of x. We have variance of x I plus yi plus zi, right? So we can actually, here this is xi plus yi plus zi, right? Same thing, right? So from here, we can expand this. So if you write the form, what this means, it means the variance of x I plus variance of plus 2 covariance x si comma I plus zi, right? Now this exactly what you've expressed this in terms of what it means, right? So now we can deal with this guy. Let's deal with this first one. This first guy can deal with this guy. So this means variance of y I plus vi. What's the meaning? From our solution from the A part and the B part, right? Such as yes, from the A part we have this means variance y plus variance z plus 2 covariance I z. Yeah, that's the A part, right? That's what we proved in the A part. Then later we can now open up this guy too. So this is just covariance. It's not variance, it's covariance. So because it's covariance, so we can express that as star star. So this is from star. So now from star star. So from star star, covariance of x, y, I plus z I equals, if you expand that, it means the covariance of x, y plus the covariance of x, z. So if you bring this, if you now substitute this guy star star and this guy star into this equation, into this main equation, let's call this main, right? So let's put for star and put for star star. So we arrive at variance of xi plus variance of yi plus variance of zi plus 2 covariance y plus 2 covariance xi plus 2 covariance xi zi, right? So once we put these two guys into this equation, that's what we get, right? So that is also proved. So now let's go to the third part of the question. The third part says, from here, prove that the variance of x equals the expected value of x squared plus expected value of x all squared. So to prove that, what's variance of x? Start from the left side as well. Of course, variance of x can be expressed as a clear value of x minus a clear value of x all squared, right? All squared. So now, if we expand this, we have, if you expand this, we have a squared minus 2 expected value of x, right? Expected value of x. Yes, sorry, this bracket is not there. Value of x. So plus the value of x all squared. So we have, so basically, I think we have expected value of a minus 2, because this times this, we have e of x, right, all squared, plus this, e of x all squared too. So minus 2 plus 1, no, it's minus 1. So we have e of x squared minus e of x squared. So now this is the formula for variance. And of course, we know that under the continuous, if you are dealing with a continuous variable, we have continuous function, we have this f of x minus, so this is proof, it's proof. So this is just an additional stuff. So you have here x, f of x, right, for continuous. So now let's move to the next one. And I've given you for continuous, so for discrete, I think it's summation x p of x p of x squared minus summation x probability of x, right? Yeah. So now let's move on. Now let's move to question so the next question says, okay, now we are to prove that if x bar, where's that question? Yeah. So we are proving this, the 4 parts now. That if x bar is random variable and a is constant, the expected value of a, v of is a, v of a 0, covariance of x and y is a, then this is this. Yeah, I think we've done this in the first question, but let's do it again, right? We have, yeah. So for the first one, prove that the expected value of a equals summation n I equals 1 a over n. So we want to prove this. Oh, sorry, I want to prove that this is equal to a. So we know that, of course, this is the meaning of expected value of a. The expected value of a just means the mean of a, right? And according to the first question that we did, right? I'll prove this earlier in the first question. So, but here we also told that that a is a constant. So if a is a constant, so that means you can just have na, right? So the summation just return to a, right? So if a is a constant, like you have, let's say you have 2 plus 2 plus 2 plus 2. So that means here now 1, 2, 3, 4. So our n here is just 4, right? So if our n here is 4, because this is constant, right? So this can just be 4 times 2, right? So this is n2, n times 2, right? So here, because a is a constant, so this summation becomes n times a, right? So now it's divided by n. Once divided by n, so n cancel at n, so we arrive at the a we are asked to prove, which is proved there. So the next one is that the covariance of xi, comma a, we are asked to prove that this is equal to 0. It's equal to 0. So now, what's the meaning of this? The meaning of this is just we express this as x minus expected value of x, right? The expected value of x, and we have here, we have a minus expected value of a. So basically, that's definition of covariance between x and a. So from here, if you look at this clearly, you'll find out that this guy is what we just proved here, right? Is what we proved here. It's a. So open up the brackets and replace a for this. We have expected value of x minus expected value of f squared, right? A minus a. So a minus a is 0. So once a minus a is 0 times this guy, so everything becomes 0. Everything becomes 0. Yes, I believe you can see this. All right. So now let's move to the next one, the variance of ax. The variance of ax. The variance of ax. So before we go to variance of ax, I just want to show you some standard rule in variance. When you have, of course, when you have okay, yeah, when you have say variance of say ay, right? If this a is a constant, because it's a constant, once this a, going to bring this a out of the variance, this a return to square. Yeah, that's variance. Yeah. So this is same as this. So basically, that's what we are asked to prove, to show how we arrive at this. So now, the variance for ax equals expected value of ax minus expected value of ax all squared, right? So from here, we can look at this. We have something is common here. We have a here. We have a here, right? So we have expected value of ax minus a expected value of x all squared. Then you can bring out a still common here. So we have a x minus expected value of x, right? which is in this square. So from here, this a gets out of this expected value because that is the variance. That is, that's the expression of the variance, right? So if this a get out of here is turned to a square, right? So with that a square, now we have expected value of x minus expected value of x, right, square. So this, as you see, is the main formula for variance, right? So formula for variance, so we have a square, variance of x, right? So that's also proved. Then we know that the variance of a constant is 0. The variance of a constant is 0. So now let's move to the V part. So where's the question? So the question says, prove that if x and y are random variable and a and b are constant, then variance of this equals this is. So this now is more like a composite function, kind of a composite now. You have x, ax minus b, not a joint one, a composite one. So here now, what we need to do here is to specify what this actually means. The variance of ax minus by. What does this mean? This is what it means. It means the expected value of ax minus by minus expected value of ax minus by, right? All square. Yeah, so that's basically what it means. So if you look at the formula for your variance, you find out that I'll assuming the whole of this is x. So just be x here, right? But because this is a kind of composite function, that's why we have. So just write it. So you can just replace the whole of this for x. So here we can open this bracket by expanding this bracket. So let's assume the whole of this is a, the whole of this is b. So a minus b, like a minus b squared, right? So if you open up this bracket, if we expand this, we have expected value ax minus expected value ax minus by plus expected value by, right? All square. Yeah, this is this guy here, not square. So from here as well, a and a is common here, right? So we can bring them out. A, x minus expected value of x, right? B and b is common here, right? Can bring that out. So b, y minus expected value of y, right? Square. So from here, if you now expand this and this, like what we have here, we have, I think the first thing is to bring out this b out of this guy. It will be b square. Why? Because we are dealing with variance. Bring out this a out of this guy. It will be a square because we are dealing with variance. So we have a square, and then we expand this according to this. We have a square, we have e, we have x minus expected value of x, right? All square plus b square expected value of y minus the value of y square minus 2ab now, right? 2a times b, right? 2ab expanding here. So we have expected value of, let me cancel this out so that you understand better. So minus, so this 2ab expected value of x minus expected value of x or the times, because that's the covariance, right? Y minus expected value of y. So, and this is exactly what we are asked to prove. Yeah, that's exactly what we are asked to prove, because this is the covariance of x and y, and this is the variance of x. This is the variance of y. So, which gives us what? A square variance of x plus b square variance of y minus 2ab, the covariance of x and y, which is proved. Yeah, so let's move on to the question. So before I move to the question, just let me digress a bit to show you the sample analog as well for what I've done so far. Yeah, because you might come across it and be wondering how to go about this. Yeah. So now what is the sample analog here? So from what we know, variance of x equals summation xi minus x bar square all over n, right? Yeah, so just want to prove that this is the same thing as summation x xi2 over n minus x bar 2, right? Yeah, so yeah, let's prove this. So starting from the left as well, so this is the main formula for variance, right? So here you can expand this. Once you expand this, you have to prove that this equals this. So once you expand this, we have summation xi squared minus 2 summation xi x bar plus summation x bar square all over n. So with that, we have summation x I2 I. This is a constant, right? Can bring this yeah, like a constant, I can bring it out of this summation. So we have minus 2 x bar, right? So we have summation xi plus, so that is not a function of I, right? So this becomes more like a constant, yeah, but it's not, and the reason is because it's not a function of xi, yeah. So the same thing applies to this. So here now, this can be n x bar square, right? So you know, all over n. So we know earlier, I think we showed that this guy, this summation I, is same thing as n x bar, right? That's this summation high here, this guy. So if that holds, then we have summation x square high minus 2x bar times nx bar plus nx bar square all over n, right? So that simply means, so you have plus, minus, sorry, minus, not plus. Let's cancel this. So you'll not be confused. So x bar I minus 2 n x bar square plus n x bar square. So minus 2 n x bar square plus 2 n x bar square, that is, you have n here, is what? So x I minus n x bar square all over n, right? So now let's split this down. Let's split it. So we have this equals over n cancel n, x bar square. So that's the proving for that. Then so the same thing actually, we know for, because that's x, this is x, right? So if you have a kind of composite that's composite variable like ax minus by, so we can do the same thing for as this. I believe you understand this. Any part you don't understand, you can always send me your question. Yeah. So for the same, for this, also for the sample, let me show you that part here. So we have ax. Let's prove that ax minus b and by equal 1 over n summation axi minus byi minus comma ax minus by. That is the bar all square. So from here, so what we can do here actually is we can open up this bracket, right? Open up this guy. Yeah, so let's open it up. That's okay from here, yeah. So we can open up this. That would be, and we know it because it's variance. I've explained earlier on. Now, if you expand this and you bring out this constant guys out, I think we have, before you expand, we have summation a xi minus x bar minus, that is after collecting like terms, collect like terms. Collect like terms, you have this a, bring this ax bar here, take this guy to the other side here. So we have b yi minus y bar square, right? So from here, when you now bring out this, when you bring out this out of the variance, right? Take this out of the variance, then expand. We can multiply n through. We can expand, multiply n through, and bring out this constant. So if you bring out this constant, you have and expand, right? Yeah, over this. So we have summation xi minus x bar square. Let's expand this. We have b, and now it's out of the variance, so it's square. Summation yi minus y bar square minus 2ab and xi minus x bar yi minus y bar is covariance, right? So now if you look at this closely now, you find out that what we have here is the variance of x, that is 1 over n times this variance of x. You have a square. So that's a square variance of x. So this is b square variance of y. Variance of y here. Sorry, this bracket's not there. Yeah. So minus 2ab covariance x, comma y, right? So this is as well proved. Now let's go on now to question 2. Wow. Question 2. Let me show you question 2 before we move on. So question 2 is a continuous, I think the continuous variable. I'm dealing with continuous variable here. For continuous, the probability density function PDF of the random variable x is f of x equals kx times 2 minus x for 0 less or equals to x less or equal to 2. So he calculates k, the constant, calculate the expected value of x, e of x, and calculate the variance of x. That's the variance, the variance of x. So we know under probability, we know that in probability is from 0 to 1, right? So it's either 0 or in between 0 and 1, or one maximum 1, right? So that's the PDF now equals to 1. So here, let's start. We have this calculate k. So f of x now is the PDF, which is f of x is the PDF, the PDF now. I mean the probability density function. So here, this now is inclusive, right? 0 to 2 inclusive. So because why we have less or equal to, this equal to sign is extremely important. It shows you, this equals to, it shows you that this 0 is inclusive. This equal to show you that this 2 is also inclusive. So if it is just less than x less than 2, that means the two extreme value will be out, right? So that means if you have, for instance, if you have 0 less than x less than 8, for instance, there's no equal sign here. So that means what we are our main range will be 1 to 7, right? Why? Because this is the extreme is excluded because there's no equal sign yet. But for here now we have equal sign, so it's going to be from 0 to 2, right? It's just by the way. So now we're going to use the integral for the f of x dx equals 1. So from 0 to 2. So if you still remember your how to go about your integration, that's the integral of this function. Let's substitute our f of x here. We have, what's f of x? F of x is the whole of this, k x 2 minus x, right, dx equals 1. So k is the constant. We can bring k, we can integrate and bring k out. So now that's k integral is 0 to, so x times this, you have 2x minus minus x squared, right? Dx equals 1. So this is x squared. So if you integrate x with respect to the x, you have x 1 plus 1 all over 1 plus 1 plus c, right? So now let's apply that to this. So now we're not focusing on the this constants now, right? So now let's apply that here. So we have k. You have k. Integrate into integration of this give us x2 over 2 minus x3 over 3, right? So we are inputting from 0 to 1, 0 to 1, no, to 2. Yeah, from 0 to 2. So what that is saying is that you have k. So we substitute 2 for all x here, minus everything again, substitute 0 for all else. So we have 2 raised to the power 2 over 2, or these two cancelled out, is 2 before we have x, or we have 2 raised to the power 3 over 2, so minus k 2 0 square over 2 minus 0 cube over 3. Everything here just becomes 0. I mean, everything here is 0 minus 0, right? Everything here is 0. So if we is equal to 1, no, everything is equal to 1, equal to 1, right? Because it's probability, right? So from here, so let's now do this. This is 2 square. This is 8 over 3 equals 1. K 2 square is 4. So k bracket 4 minus 8 over 3 equals 1. K 4 minus 8 over 3 equal 1. So you can do your algebra. So let's do this together. So we have, this is over 4 over 1. Here we have the LCM of 1 and 3 is 3. 1 into 3 is 3. 3 times 4 is 12. Let's open up this bracket, 12k minus 3 into 3, 1. 1 times 8, 8k equals 1. Cross multiply, you have 12k minus 8k, right? Equal 3. So 12 minus 8 gives us 4k equal 3, k equals 3 over 4. So we know our constant now. Our constant is 3 over 4. So anywhere we see k, we know it is 3 over 4. So now the next question is to now calculate the expected value of x. What's the expected value of x? Like I've shown you before, expected value of x under this continuous function, we have is x f of x dx, right? Then the variance is this expected value of x. So variance of x under this is expected value of x squared minus expected value of x squared minus expected value of x all square. That is expected value of x squared minus expected value of x all square. So here we have, what is this guy? So this guy is so this guy under this function. So expected value of x is integral of s squared f of x dx, right? This is just this guy, the mean. You square the mean. The expected value of x, which is the mean, the value of x all square. So this formula, you need to know them by heart. But here, for now, our interest is getting this mean. So to get the mean expected value of x, let's move on. We know is x f of x, and that's the integral of x f of x. F of x here is x, k, sorry. Yeah, we have k, x 2 minus x dx, right? From 0 to 2, right? So here, just like what we did before, but this time around, you multiply it through by x. So you have k outside, because the constant, and we know what our constant is from what we did before, 0 to 2, x times x, x times x times 2, we have 2s squared, then minus x times x times x, we have x3, right, dx. So here, we can just find the integration of this, which gives us 2s cubed over 3, our k is outside, minus x4 over 4, from then input from 2 to 0. So basically, when you put 0 to substitute 0 for x, everything becomes 0. But when you substitute 2, so substitute the first 2 to all the x minus substitute 0 to all the x. So I won't spend that time. I won't spend time on putting the value 0. Just focus on this. So our k is 3 over 4. Then we have our 2, 2, 3 minus 2 raised to the power 4 over 4. So when you substitute 2 into everything, so again, I have to substitute 0 to everything, but I know everything will give me 0. So when you now do the algebra, 3 over 4, right? So this gives us 4. Is it 4? No, it gives us 16 over 3, right? 16 over 3 minus 16 over 4, right? So let's continue. Oh, we need some empty sheets. Yeah. Just let me know, all these questions can be done within an hour, actually. Just that you have to be very fast. So now let's move on from where we stop. We have 3 over 4. The last equation I wrote was 3 over 4, 16 over 4, right? Yeah. So from here, this 4 can cancel this. You have 4, 4, right? So you're left with 3. You're left with 3 here. 4 over 3 minus 4 over 4 basically. So that's, of course, that's 1. But now let's bring out what is common here. We have 2, right? So we have 2, that's 6. We have so 2 over 3 minus 2 over 4, right? So basically, yeah, that's what we did before. We have, take the LCM, of course, we have, yeah, this can break this down to 1 over 2. So 6, 2 over 3 minus 1 over 2. Take the LCM of this, that's 6. 6, 3 into 6, 2 times 2, 4. 2 into 6. Of course, we know it's 3. 3 times 1 is 3. 6 cancels 6. 4 minus 3. So I mean is 1. I mean it's 1. So I just subtracted this from this. So you can use any method. You can always use any method, So now let's go to the variance. So the variance, the variance here we have the expected value of the variance of x, expected value of x minus expected value of x or square. This is a expected value of x. So this just means 1 square, right? So but let's deal with this first. So dealing with this, we have expected value of x squared. We have integral from 0 to 2, that's our range. S squared, right? That's the formula. F of x dx. So 0 to s squared x. So k x 2 minus x dx. Right. Yeah, let's move on. So open up the bracket. We know what our k is, right? Just bring the k out. Just bring this k guy out. So we have k integral x squared times x times 2, 2x3 minus x squared times x, x4, right? So dx. So we know our k is 2 over 4. So if you integrate this, this gives us 2x4 over 4, right? Minus x5 over 5. Input 0 from 2. Yeah. So from here, we know if you substitute 0 to the 2 throughout, then minus 0 throughout. The 0 part will be 0, of course. So from here, put 2 in here, you have. So basically, let's just cancel this out. This goes here, this goes here, 2. So putting 2 here, we have 3 over 4, 16 over 2 minus 2 in here, 32 over 5, right? Minus 0, of course. So this gives us Let's break it down. Let's break this down. So what is common here? We know that 16 is common. Just bring 16 out. 16 is common here, right? 16 out. So we have 16 times I think there's 3 here. We have 48 over 4, 1 over 2 minus 5 over, 2 over 5. So break this down, you have 12, 1 over 2 minus 2 over 5, 2 over 5, right? So we have 12, take the LCM of these, subtract, that's 10, that's using to this, that's 5 minus 4 over 10, right? So here we have, this goes here, we have 6 over 5. So our expected value of S squared there is 6 over 5. So now to get the variance, we subtract the square of the expected value of X from this. So that's what I showed you before. So we have expected value of X, which is 1. And our variance, we know, of X, we know is the expected value of S squared minus expected value of X all square. So that's 6 over 5 minus 1 square. So that gives us, of course, this is still 1, 6 over 5 minus 1, that's 1 over 5. So that's variance. So we're moving on. Let's move to question 3. Question 3. Yeah, that's question 3. Yeah. So here, calculate the following formula when the density function is f, x plus y is equal to x plus y rather. So now x from 0 to 1 inclusive, y 0 to 1 inclusive. So get the expected value of x, variance of y, expected value of y given x. So this is a joint function, actually, it's a joint function. So from the joint function, we are asked to find expected value of x. So for we to get the expected value of x from the joint function, I think the first thing we need to know is to get the PDF of x. Now this is the PDF of x and y. So we need the PDF of x alone to be able to do this. Then we need the PDF of y alone to be able to do this. Then we need the PDF of y given x to be able to do this. So you need to always know that, right? So you need to extract out the PDF for these guys, in order to go further. So now let's start from the first one, right? So from the joint function here, what's the PDF of x, right? So now to get the PDF of x, of course, we need to do, I think, integrate this with respect to y. That's partial integral of this with respect to y, so that we can eliminate y out and get the PDF of x. So we have now what's the PDF of x, f of x. This is small f here, of x, because the integral of 0 to 1, because right, that's y. Y is from 0 to 1 because we are integrating with respect to y, right? We are integrating with respect to y. So we have f of x, y, See, so which is 0, 1, x plus y dy. So now because we are integrating with respect to y, x becomes a constant, right? So it functions like a constant. So if you function like a constant, we have integral is to this, so we have xy, right? So this becomes s squared over 2, right? So, oh, sorry, this bracket because I've done the integral. Yeah, I've done the integral already. So xy like this. So it's from 0 to 1, right? So put your 1 here for eliminate for the y because we integrated with respect to y. So we have your x1 plus 1 square over 2 minus x0 plus 0 square over 2. All of these becomes 0. This becomes x plus 1 over 2. So we know that the PDF of x is now x plus 1 over 2. So with that information, we can go on to calculate the expected value of x. So the expected value of x now will give us integral of from 0 to 1 x f of x dx. So here we have integral. So x, so our f of x is now x plus 1 over 2, right? Dx. Now we are integrating with respect to x here, right? Because we are looking for the expected value of x. But initially why we integrated with respect to y, because we needed the PDF of x, so we need to integrate with respect to y. So if you are looking for the PDF of y, you need to integrate with respect to x. But here we are looking for the PDF of x. That is why we integrate with respect to y. After doing that, we now substitute for y. So we are left with only a function that has an equation, right? That has x, right? So now, because we are looking for the mean of x, that is why we integrate with respect to the x. So don't make that mistake. Don't make any mistake. Just note that if you are interested in the f of x, you have to, if you are extracting it from the joint function here, from the joint function. If you are doing that from the joint function, have a joint function, and you're interested in looking for f of x, you need to integrate with respect to y. You need to integrate with respect to y to get the f of x. If you are looking for the that is the f of y, the marginal PDF, right, from this joint function of y, right? For the joint function, the marginal function now for y. So you integrate with respect to x. So as to eliminate that of x and have y. So here, let's go on here. So we have, when we integrate this, we have s cubed over 3 plus x squared, right? Over, we have half here, right? It's like a constant here, we have s squared over 4, right? So 0, 1. So we integrate this with respect to x, we have x squared all over 2. So times half, s squared all over 2 times half. That's how we got here. Don't be confused. So with this, let's work it out. Separate sheet here. So from here, let's substitute for 1. Substitute for 1, you have your 1 over 3 plus 1 over 4 minus 0, right? So this gives us 12, 3 in 12, 4 in 12, 3, that's 7 over 12. So the expected value of x, 7/12. Okay. So let's go on. Let's go on. We're almost there. So the variance of y. Now, so the variance of y we know is the variance of y we know is the expected value of y squared minus the expected value of y all squared. So calculate f of y first. We need to get f of y first. So of course, from the joint distribution, f of y is this integral 0 to 1 x plus 2. We integrate with respect to what? Exactly with respect to x. Why? Because we are extracting the PDF of y. So we integrate with respect to x and then substitute for the x values in order to eliminate, filter out the x value and be left with y. So here we have okay, let's integrate this. We have we integrate now. We have with respect to x, you have x squared over x over 2. With respect to x, y is seen as a constant because we are integrating with respect to x. So that's xy, right? So substitute 0 to 1. So we have now put 1 for all the value of x. You have 1 over 2 plus y. Because put 0 it be minus 0. That's so the PDF of y is this, right? Of course, you know that this is actually what this 0 over 2 plus x 0, right? No, sorry, it's y. So y, okay, this x now. So yeah, so all this is 0. That's why I didn't include it actually. So what we have is 1 over 2 plus y. So that's the PDF of y. So with the PDF of y, that means you can now move on to solve for the variance of y as required, the variance of y as required. So the variance of y as required, we need to find the expected value of y squared and also the expected value of y all squared. So without the expected value of y now is integral from 1 to 0 y f of y dy, right? All this formula, you need to remember these formulas. So formulas are important. So here, that gives us integral. We have y. What's f of y? Here, 1 over 2 plus y, right? dy. So when we integrate this, we have y squared over 4, y cubed over 3, 0 to 1. So also put 1 throughout, we have 1 over 4 plus 1 over 3, right? Also put 0 throughout, minus 0. So that gives us expected value of y, gives us what? 7/12 still. 7/12. So having done that, 7/12. So having done that now, we know e of y gives us this. So then now let's go for e of y squared. E of y squared. Just a new sheet here. E of y square. So E of y square here. E of y square here. E of y square will be integral 0 to 1, right? Y square, E of y square. So multiply f of y by y square because we are looking for E of y square, right? So f of y dy. So that gives us integral 0 to 1. What's f of y? We have 1 over 2 plus y dy now. So from here we have integral 0 to 1. We have half y squared plus y cubed, right? Dy. So here we have, once you now integrate this as y cubed over 3, 1 over 2 y cubed over 3 plus y4 over 4. Substitute from 0 to 1, right? For y, right? So you have y3 over 6 plus y4 over 4, right? So 0 to 1 substitute, we have 1 over 6 plus 1 over 4, that's 5 over 12. So our E of y square now is 5 over 12. So now to get the variance now, like variance of y, like you know before, I've said before. Now this is E of y square, and then we know our E of y to be 7 over 12, right? So this 5 over 12, 7 over 12. So the variance now is this minus the square of this. So that would be 5 over 12 minus 7 over 12 or square. So that gives us what? If factor that out, 49, 144, that will be 11 over 144. Yeah. 11 over 144. 11 over 144, yeah. So that's the variance now for y. So just note all of this. If you can follow up the video clearly, you get this step easily. It's actually not difficult. So the third question now. The third question was to get, we're asked to get, yeah, expected value of s given x. Right, that's the third question. Let's get a new sheet. So if you go back to the question, we're still using that same joint function, right? So we have so this gives us yeah, to get this given x. So now, once you have expected value of y given x, a way to go about that actually is to find the expected value of, the joint. Yeah. So find the joint PDF divided by the marginal PDF of x. So that gives you the f of y given x, right? You need to first find the f of, to get this, we need f of y given x, right? before we can look for the mean. We need the PDF. We need the PDF. So here, the PDF is actually f of x comma y, that's the joint one, that's the number we are given, divided by f of x. And right? So we know from what we are given, we know that this is x plus y. And from when we solved in the past, we know that this is x plus half. So it does this, then f of y given x is what? X plus y all over x plus half. So basically this is the PDF. So now if you are now if we now to solve for this, you have x of y given x, you have equals to this guy. This is our interest, right? Given this, this has happened. Now here, this has happened. So what is this when this has happened, right? So our main target is this, right? So we have 0 to 1, we have y x plus y all over x plus 1 over 2 dy, because the interest is dy, right? Dy, right? Now from here, you can move on from here. We can manipulate this. You have x plus half first thing, then we have that's 1 over 1, right? 1 over 2, x over 1 plus 1 over 2, LCM's 2. This is 2x plus 1. Then if you if you divide that, you divide this by this, you have 1, you have y, you have 2y, right? X plus y all over 2x plus 1. Yeah, this is just algebra. Just add this together to get a single equation, then divided by this, division, the 2 goes up, the 2x plus 1 comes down, then multiply the 2 by 2y, you get this. So dy. So now from here, we can now start to do the integration. Let us do the integration now. So when we integrate this, we are integrating with respect to y, don't forget. So if you're integrating with respect to y, that means the x is seen as a constant, right? The x is seen as a constant, as long as the x is independent, but it's not dependent on the y. So it's not a constant. So here we have, let's bring out the x here. So we have 2x plus 1 times y, x plus y, right? dy equals that's 2x plus 1 integral 0 to 1 y x plus the x, right? So here, just do the integral. We have 2 over 2x plus 1 is times this x, that's y squared over 2 times the x, right? Plus y, that's y squared, that integrates 3. So it's 0 to 1. So yeah, of course, when you subtract 2 to 1, so 2 to 1 to all of the y's minus substitute 0 to all of the y's as well. So the part substitute 0 to everything will be 0. So I won't focus on that. I'll just look at this, right? So I think it's clearer that way. Over 2x plus 1. So here, substitute 1, we have x over 2 plus 1 over 3, right? So from here, that that gives us 2x plus 1. Now you can look for the LCM of this. That's 6, right? That gives us 2 and 3, that's 6. 2 into 6, 3 times x, 3x. 2 times 3 into 6, 2 times 1, 2. Right? So if you have that, 2 cancel this, 3. So we have 3x plus 2 all over 6x plus 3. So this is the expected value of y given x. Yeah, that's number 3. Yeah. Yeah. So now let's move on to the 4th part. Number IV. IV is you're asked to prove. For IV, you're asked to prove verify the so-called law of iterated expectation. That is that the expected value x, or expected value of this across x, right, equals expected value of y. Expected value of this across x is equal to expected value of y, right? So that's what we are asked to prove. So now let's go on. So expected value of expected value of y given x, right, across x, right? We want to show that this is equal to expected value of y. And we know our expected value of y. We've done that before, right? We've done that before. We've done that before, and we know our expected value of y. We know that this guy was then expected value of y was 7/12, right? So we want to solve for this now to show that this is equal to this as well. So then now let's go on. So this equals this guy equals integral, is from 0 to 1. So expected value of the expected value of this. So since the expected value of this, so this is the main, this would be more like your x, your x when you say the expected value of x. So, right? So everything here becomes x times f of x. Now, you are now dealing with this now. So this will be the whole of this, right? Right? The whole of this now times the PDF of x. The whole of this times the PDF of x, right? So more like you say the x times what? F of x. So here now we have e y given x, f of x dx. Why is the f of x? Because of this, it's across x, right? So this times this. So if you want to find the variance, you find the square of this times this minus E of X of this. I mean, that's for the variance, right? But now what we're looking for now is the mean. So now let's go on. With that, this gives us, we know this is what we have solved earlier. We solved this to be this, right? This guy, expected value of y given x, we know that it's this. So that would be integral 0, 1, 3x plus 2 over 6x plus 3 f of x dx. That gives us, we know f of x to be x plus 1 over 2 that we've done in the past. You can check. So we have integral 0 to 1, 3x plus 2, 3x plus 6, x plus 3 times x 1 over 2, yeah, x plus 1 over 2, x plus 1 over 2 dx. So here we have the integral of 3x plus 2 all over 3, 2x plus 1 if you factorize the common terms. So add this together, right? Find x over 1 plus 1 over 2, add this together, we get 2x plus 1 over 2 dx. This cancels this. We have bring this out times this. We have 1 over 6 integral 0, 1, 3 plus 2 dx. So we've simplified it to this term. So from here, we can now move on to integrate, find the integral. So we have 1 over 6. We have integrate this. So we have 3 with respect to dx, 3s squared over 2 plus 2x. So when you put 1 true, minus when you put 0 true for x. So here we have 1 over 6, 3 over 2 plus 2, because 2 times 1 is 2, right? So now add this together, you have 1 over 6 plus 7 over 2, which gives us, if you add this together, it gives us, of course, the estimate of 6 and 12, that gets 7 over 12. This is exactly the same thing as the expected value of y, as you can see, right? Same thing. Yeah, so that's proved. So now let's go to the V part. The V part asks us to find, the V part, let me show you the question again. Find the variance of y given x. The variance of y given x. So the variance of y given x, of course, we know we have to look for the expected value of y given x square minus the expected value of y given x all square. And I think we have done this. We have gotten some of this before. So V part now, find the variance of y given x. So We know that our f of y given x was x plus y over x plus half. So the variance of y given x will be expected value of y square x minus expected value of y given x or square. So from the number 3, from the I, the one we did before we get here, this is v. So from this I, we know we're able to resolve that our expected value of y given x gives us this answer plus 2 over 6x plus 3, right? So expected value of y given x, that's what we want to solve now. Of course, it's 1 to 0 y square f of y given x dx. Dy, sorry, dy, because our interest is this y. Interest is this y, so dy. So from here, just put in what our f of x is here, 0 to 1, y square x plus y equals x plus half dy. So this is equal, of course, when you manipulate this as we did before, 0, 1, right? You have y square, just this, you have 2x plus y all over 2x plus 1 dy, which gives us was 2x plus 1. Bring out what is common for as x plus x, the constant we had integrating with respect to y dy. Yeah, so just bring out this 2 over 2x plus 1. So we are left with x plus 1, x plus I, y plus times y square, right? Dy. So when you integrate this, we have 2x plus 1. So this times this, we have x y cubed over 3 plus y4 over 4. Substitute from 0 to 1. So here we have 2x plus 1 and substitute. So find the LCM, add this together. Once you add this together, I'll substitute 1 for each y. You get 4x plus 3 over 12. So this gives us 6. This here 1. So you have 4x plus 3, 6, 2x plus 1, right? So now, since we have that, we can now find our variance. So our variance of y given x is the expected value of y square given x, 4x plus 3 over 6, 2x plus 1 minus the expected value of y given x, which we solved before, to be this guy here. 3x plus 2 over 6x plus 3 squared. So if you factor this out, manipulate this, it gives you 1 over 36. 3 minus 1, 2x plus 1 squared. Yeah, so it gives this. 36. Yeah, so that's it. Let's move to the last question, which is question 4 now. So the last question says, suppose y is this x, where x and 2 are independent random variable. This is important here, independent random variable, with mean 4 and 0 respectively. That's the mean of x is 4, the mean of error is 0, and the variance of x is 2, variance of error is 1 respectively. Calculate variance of y. So now, solution. For 1, the variance of y is, this is y, right? So just find the variance of y. So we have variance of y equals variance of 2 plus 3x plus error, right? The variance of 2 plus variance of 3x plus variance of error. So variance of 2 is what? 0, the constant, right? Variance of constant gives 0. Variance of, when this is a constant, so you bring the 3 out, so that becomes 3 squared, like I've told you before. So variance of x. So then variance of error, we are told that variance of error is what? We are told that variance of error is 1, right? And so I told that variance of is 9, variance of x. We are told that variance of x is what? 2 plus 1. So 18, that's 18 plus 1, that's 19. First one is done. So then let's move to the second one. Second one says, calculate the expected value of y. I will know what our y is. So expected value of y gives us expected value of 2 plus 3x plus error. So here we have e of 2 plus e of 3x plus e of error. So from here, we know e of 2 is a constant, expected value of a constant is that constant. So 2 plus expected value of 3, bring 3 out, right? 3. Expected value of x, we are told is 4, right? From here, expected value of x, we are told is 4. So we have 4 plus expected value of error, we are told is 0, right? So it's 0. So that gives us what? 14. That's give us 14. Let's move on. Now, 3 parts, right? Calculate the expected value of y given x. Expected value of y given x. Expected value of y given x, yeah. So for that, we have expected value of y given x, the expected value of, our y to be 2 plus 3x plus error, all given x. So we have expected value of 2 given x, expected value of 3x given x, expected value of error given x. So expected value of course, this is a constant there, yeah. So it's 2. Expected value that we bring this 3 out, expected value of x given x, expected value of x given this, we know this to be error, expected value of, because this is independent, error, x, they are both independent, right? Independent random variable, x and error independent. So if they are independent, then they don't have any relationship. They are not mutually mutually inclusive. Yeah, they are mutually excluded, right? So here now, so because they are independent random variable, right? They are independent of each other. They don't rely on each other. So here, that is 0, right? So from here, we know e of x given x is 3x, right? So we have 2 plus 3x. So now let's go to 4. Oh, sorry, 4. So 1v. So calculate. So 1v asks us to calculate the value of this guy across x, the value of x, just like what we did before, the expected value of x over x, and verify the law of iterated expectation. Verify that this is equal to this. So here we find expected value of y. We've done this, expected value of y. So we need to prove that this guy, we need to prove that this guy here equals 14, equals the value of y, which we've done before, right? So now let's go. So we have expected value of the expected value of y given x. Prove that is equals to this. So now, since our expected value of y given x equals 2 plus 3x. Yeah, we've done that, yeah, right? Plus 3. So we can substitute this now for this guy. So we have expected value across x here, 2 plus 3x. So expected value of a constant, plus expected value 3x here, it's x. So this is 2, the constant. This is bring 3 to expected value of x. We're told this is 4. That was given 2 plus 3, 4. That's 2 plus 12 gives us 14. Proved. That's proved because initially what we calculated as expected value of y is still 14. So this also is 14. That's proof. So now let's go to the V part. For the V part, we are asked to calculate the variance of y given x. So we know what our y is. So the variance of y given x is variance of 2 plus 3 plus error given x. So the variance of 2 given x plus the variance of 3x given x plus the variance of error given x. So variance of 2 is a constant given x, right? So it is a constant. So it has because x is independent, right? It's a constant, so it's still going to give us 0 anyway. So bring out this 3 constant when it's because it's coming out of variance, right? That's 3 squared. Variance of x given x, variance of error given x. Variance of error we are told before is 1, right? So variance of x given x, that gives us, that will be 9, 0 plus 1. That gives us 1. So that's all the question for now. If you have any question, you can always send me and let me know which area you don't understand. So that marks the end of the solution to this set. Thank you for watching. Bye.